Have you ever gazed up into the night sky and wondered if we are alone in the universe? It's a question as old as humanity itself, a cosmic inquiry that has sparked countless philosophies, religions, and science fiction tales. Consider this. The universe is immeasurably vast, home to an estimated 2 trillion galaxies, each one teeming with billions of stars. Around these stars orbit countless planets, many of which may lie within their star's habitable zone, the so-called Goldilocks zone, where conditions might just be right for life as we know it. Yet despite the seemingly infinite possibilities, we've yet to encounter any signs of extraterrestrial life. This conundrum, known as the Fermi paradox, named after physicist Enrico Fermi, leaves us scratching our heads. With such a vast cosmos, why haven't we detected a whisper, a signal, a sign of life beyond our planet? But what if the answer to this paradox lies not in the stars but here on our own planet? Enter the rare Earth hypothesis, a controversial answer to the Fermi paradox. So what exactly is this rare Earth hypothesis? In essence, it's a theory that suggests Earth, with its life-supporting conditions, is not just rare, but incredibly unique. The hypothesis posits that the existence of similar planets, capable of supporting life as we know it, is highly unlikely. But why is Earth considered so special? What makes it the proverbial needle in the cosmic haystack? Firstly, consider the Goldilocks zone, or habitable zone. This is the perfect distance from a star where it's not too hot nor too cold, but just right for liquid water to exist on a planet's surface. Earth sits comfortably in the sun's Goldilocks zone. Next, think about Earth's magnetic field. Generated by the swirling molten iron in our planet's core, this invisible shield protects us from harmful solar radiation. Without it, life on Earth would be a lot less pleasant, if not outright impossible. Then there's Earth's moon, our ever-constant companion in the sky. The moon stabilizes Earth's axial tilt, providing us with a relatively stable climate. It also contributes to the tides, which play a crucial role in our planet's complex ecosystem. Let's not forget about plate tectonics, a unique geological phenomenon to Earth. This process recycles carbon dioxide, preventing a runaway greenhouse effect that could render the planet uninhabitable. Lastly, Earth's biodiversity is a testament to its habitability. Life here has evolved and adapted to fill every conceivable niche, from the deepest ocean trenches to the highest mountain peaks. Each of these factors and others play a vital role in making Earth the habitable planet we call home. The rare Earth hypothesis argues that the chances of all these factors aligning on another planet are astronomically low. Yet the universe is vast and filled with countless stars and planets. Could Earth truly be the only planet among them to harbor life? Is our planet really that rare? But is the rare Earth hypothesis the definitive answer to our cosmic question? Like any theory, the rare Earth hypothesis has its critics. It's a compelling concept, no doubt, but it's not without its fair share of skepticism. One of the main criticisms revolves around the assumption that life can only exist under conditions similar to Earth's. This is what we call the principle of mediocrity, which posits that our planet isn't particularly special or unique in the grand scheme of the cosmos. As a result, it suggests that life as we know it should be common throughout the universe. However, the rare Earth hypothesis counters this by arguing that our planet is indeed unique, and the conditions required for life are not as common as we might like to think. But here's the thing. The assumption that life requires conditions like those of Earth might be a bit narrow-minded. Life on our planet has proven itself to be incredibly adaptable, thriving in environments once thought to be inhospitable. From the scorching heat of desert sands to the crushing pressures of the deep sea, life finds a way. Isn't it possible then that life could adapt to conditions vastly different from those on Earth? Another criticism of the rare Earth hypothesis is that we may be overlooking unconventional forms of life. Our search for extraterrestrial life is primarily based on our understanding of life on Earth. But what if life elsewhere doesn't play by the same rules? What if it's not carbon-based or doesn't require water? What if it exists in states or forms that we can't even fathom? It's a humbling thought, isn't it? These criticisms aren't intended to debunk the rare earth hypothesis, but rather to challenge it, to push the boundaries of our understanding. After all, science is all about questioning, exploring, and learning. And the more we learn, the more we realize how much there is yet to discover. So, where does this leave us in our quest to answer the question of extraterrestrial life? Well, as with any good mystery, the search continues. Despite the debates, the search for life beyond our planet continues. Our curiosity, our thirst for knowledge propels us forward, pushing the boundaries of our understanding. We've sent rovers to Mars, probes to the outer reaches of our solar system, and telescopes far into the depths of space, all in the name of exploration and discovery. Current missions such as NASA's Mars 2020 and the European Space Agency's ExoMars are actively investigating the red planet for signs of past or present life. These rovers are not just looking for little green men, but for subtle signs of microbial life, evidence that Mars may not always have been as desolate as it appears today. And let's not forget about the hunt for exoplanets. These are planets outside our solar system, orbiting around other stars. We've discovered thousands of them already, and a handful of these distant worlds sit comfortably in their star's habitable zone, the so-called Goldilocks zone, where conditions might be just right for life as we know it. Looking to the future, missions like the James Webb Space Telescope are set to open new windows into the universe. Set to launch in the near future, this remarkable piece of technology will allow us to peer deeper into space, to observe these exoplanets in more detail and perhaps, just perhaps, find signs of life. Meanwhile, here on Earth, scientists continue to study extreme environments, from the boiling hot springs of Yellowstone to the icy depths of Antarctica. These studies help us understand how life might survive in the harsh conditions of other planets. The rare earth hypothesis suggests that life, especially complex life, is a cosmic rarity. But every day scientists around the world are working tirelessly to challenge this notion, to find that one piece of evidence that tells us we are not alone. While the rare earth hypothesis poses interesting arguments, it is clear that our search for answers is far from over. So, are we alone in the universe? This question has been the crux of our discussion today. It's a question that's been asked since the dawn of human consciousness, and one that we still grapple with in the 21st century as we delve deeper into the mysteries of the cosmos. We've journeyed through the rare earth hypothesis, a theory that posits that the conditions necessary for life as we know it are incredibly rare in the universe. It suggests that a myriad of specific circumstances, from the type of star around which a planet orbits, to the presence of a large moon, to the right cocktail of chemical elements, must align perfectly for life to emerge. In essence, this hypothesis paints a portrait of our Earth as a cosmic lottery winner, a precious gem in the vast, often inhospitable expanse of the universe. Critics of the rare Earth hypothesis argue that it's based on a limited understanding of life. They contend that life might exist in forms and environments that we can't even begin to comprehend. They argue that it's presumptuous to assume that life elsewhere must mirror life on Earth. The universe, after all, is a place of infinite possibilities. In our ongoing search for extraterrestrial life, we've sent probes to the farthest reaches of our solar system, and we've scanned the skies for signals from distant stars. We've found tantalizing hints. Planets in the habitable zones of their stars, water on Mars, organic molecules on distant moons, but as of yet, no definitive proof of life beyond Earth. But what would it mean if we were to find such proof? How would it change our understanding of the universe and of ourselves? Would we feel less alone or more? Would it inspire awe or fear? Would it humble us or would it feed our hubris? These are questions that extend beyond the realm of science, delving into philosophy, theology, and the human psyche. Yet, despite the uncertainty and the unanswered questions, we continue to search, we continue to question, we continue to explore. Because that's who we are. We're a species driven by curiosity, by a desire to push the boundaries, to seek out the unknown, to understand our place in the cosmos. As we continue this journey of discovery, we must remain open to new ideas and possibilities. We must be willing to challenge our assumptions, to question our beliefs, to admit when we don't know. We must remember that science is a process, not a destination. It's a journey of discovery, of learning, of growth. So, as we continue to gaze into the cosmos, the question remains, are we truly a rarity in this vast universe? It's a question that fuels our curiosity, that drives our exploration, that defines our humanity. And perhaps one day, we'll find an answer. Until then, we'll keep asking, we'll keep searching, we'll keep wondering, because that's what it means to be human.